All right, this is section 9.4. We leave aside the idea of limits now, and we use very specific rules to find the derivative, which is a lot simpler than having to use this cumbersome idea of limits. So, the first rule that we understand is the power rule. Power rule says that if you've got some number, some variable raised to a power, you just bring that exponent out front and you subtract 1 from the exponent. So if you got x to the 14th, you bring the 14 out front and subtract 1 from the 14th, so your answer is 14x to the 13th. For x to the negative 2, you bring the negative 2 out front and subtract 1 from the negative 2, it gives you negative 3. Keep in mind, you want to write things with positive exponents, so you have to cross the fraction bar with the negative 3 and write it as a positive 3 in the denominator. Remember, when you move something up or down across the fraction bar, it changes the sign of the exponent. All right. So x, or x to the first, you bring the 1 out front and subtract 1 from the 1, you get 0. And anything to the 0th power just equals 1. X to the 1/3, you bring the 1/3 out front, subtract 1 from the 1/3, you get x to the negative 2/3 and a 1/3 out front. You can cross the fraction bar with that, and it becomes a positive 2/3 in the denominator. There's different ways that you can write these things. You can, instead of saying g prime or f prime, you can write d dx of y equals d dx of x to the 14th, which gives us dy dx of x 14x to the 1/3. And you can write d dx of x to the negative 2 equals negative 2x to the negative 3. Different ways of writing your answers for derivatives. Example 2. Example 2 says s to the 8th. So you bring an 8 out front and subtract 1 from the 8. Q to the 2/3, you bring 2/3 out front, subtract 2/3 from 1 from the 2/3, you get minus 1/3. And you cross the fraction bar with that. And 1/3 power means third root of x to the 1. Square root of t is t to the 1/2. Remember, the exponent is your power. In case you can't see it, it's a 1 there. And your root is 2, so your denominator is 2. Alright, so you bring the 1/2 out front, subtract 1 from that, and you get 1/2 t to the minus 1/2, which is 1 over 2 t to the positive 1/2. And you can rewrite that with the square root of t. Here you rewrite 1 over the square root of t as 1 over t to the 1/2, and when you bring it up top, it becomes t to the minus 1/2. And so to take the derivative, you bring the minus 1/2 up front, subtract 1 from the minus 1/2, you get minus 3/2 in your exponent there. Cross the fraction bar, it's t to the 3/2 positive in the denominator. And that means third power, second root. Notice the 8th root of t to the 9th is t to the 9/8. Those are equivalent statements. Example 3. They want us to find the equation of the tangent line to the graph at x equals 1. At x equals 1, you're looking at the point 1, 1. And this is going to be what your line is. Now, how do we know what that line is? Well, we first have to find the point. You have to plug in 1 into the function to get the y-coordinate of 1. So now we know the point we're looking at is 1, 1. But to find the equation of the tangent line, we need to know the slope. So we take the derivative first, find that. Then we plug in 1 into the derivative to find the slope at 1. And so the slope is 3, and the point is 1, 1. So we plug that into the equation, and we find our answer, 3x minus 2. And so all that jives with this. This is a line that crosses at, touches at 1, 1, has a slope of 3, and it's 3x minus 2. Constant function rule. If you take the derivative of a constant, your answer is 0. Now that makes perfect sense, because if you draw a line of y of f of x equals a number like 7, it's a horizontal line, and all horizontal lines have slope 0. And remember, the derivative is the same thing as the slope of that line, which is 0. So they ask you to find the derivative of y equals 4. Well, it's 0. They ask you, now they're saying, what's the coefficient rule? Meaning some number out in front times a function is just the number out in front times the derivative of the function. So if you're taking the derivative of 4x to the 5th, you you leave the 4 out front and you take the derivative of x to the 5th, which is 5x to the 4th. And now you clean it up by multiplying the 4 and the 5 to give you 20. 1/2 t to the second is 1/2 times the derivative of t to the second, which is 2t. And 1/2 times 2 is just 1, or 1t, so it's just t. 5 square root of t is 5 over the square root of q is 5q to the minus 1/2. So the 5's out front, you bring the minus 1/2 out front and subtract 1. And when you clean this up, you're going to bring that downstairs and write it as square root of t cubed. Example 6, talking about this guy here. This is a formula that projects the number of internet users based on the year, where x is the number of years after 2010. So it says, name the function that models the rate of change in the number of internet users in Latin America. Well, that's the derivative. B says, find that function. So we're going to take the derivative. We leave the 201 out front. We bring the exponent out front and subtract 1 from the exponent. And we multiply those two to give you 60.3. We subtract 1 from that to give us negative 0.70. Now it says predict the rate of change in 2025. Remember, x represents years after 2010. So that would be x equals 15. So you plug 15 into the derivative and you get 9.06. And that's the number of internet users in Latin America is going to increase by 9.06, and it's in millions between 2025 and 2026. Now the sum and difference rules are simply if you've got a function equals one function plus another function, it's just the derivative of each individual term. And subtraction, it's the same thing. So then they ask us to find the derivative of 3x plus 5. Well, you take the derivative of 3x and you take the derivative of 5. Derivative of 3x is just 3 times 1, and derivative of 5 is 0, so your answer is 3. This one's derivative is 4 times 3x squared. It's 2 times 2x. It's 5 times 1, and it's 0. And you simplify to give you 12x minus 4x, 5, and there you go. This one is 1/3 times 3q squared. This is 2 times 2q. And that one is 0, and so that gives you q squared, that gives you 4q. This one, you leave the 5 out front and you bring the 4 out front and subtract 1 from the exponent. 1/3 out front, subtract 1 from the exponent, and you simplify it to here, and now you cross the fraction bar with that. I could have written that as the cube root of x squared, but I just chose to leave it that way. This one is, remember this is x to the 1/2, so the derivative is 1/2 x to the minus 1/2, and 3 times 4 is 12, subtract 1 from 3, you get 2. And when you bring that across the fraction bar, it becomes a positive 1/2, which is the same thing as the square root. And this one, that one is 30 t to the 5th, and remember that 1 over t squared is t to the minus 2, which is minus a negative times a negative 2, t to the minus 3. That makes it positive 2 t to the minus 3, and you cross the fraction bar and make that t to the positive 3. Example 8, they say, what is the total personal income for the year 2020? And remember, t is the number of years after 1960, so in this case t would equal 60, and you plug 60 into the function, and you get $19670 billion. B says find the rate of change of the personal income. So now you're asking to find the derivative. So you bring the 2 out front and subtract 1. You take derivative of this guy and that guy, and you end up getting this derivative. Now they ask you to find the rate of change for t equals 60, and so you just plug 60 in for t, and you get this number here, which predicts that the total U.S. personal income will increase by $684.7 billion from the year 2020 to the next year, 2021. Find all points on the graph where the tangent line is horizontal. Well, if you take the derivative and set it, when you take the derivative, you get this guy. Set it equal to 0. Factor, solve for it, and you get these two values here. Now these two values here are where the first derivative equals 0, and those are points where the tangent is horizontal, meaning it has 0 slope. And so at negative 5, and at positive 3 you've got tangent lines that are horizontal, and they want to know the points, so you have to find the y-coordinate. You plug the minus 5 into the function and 3 into the original function, and you get your y-coordinates for each one. Marginal revenue is simply the revenue function's derivative. And so when they ask you to find the marginal revenue at 500, you have to take the derivative of the original revenue function. And you get this guy here. You plug 500 in, and you get your marginal revenue at x equals 500. Now they say find the change in revenue caused from 500 to 501 units. Well, you plug 500 into the original function, and you get this. Plug 501 into the original function, you get that, and their difference is this amount here. Well, we said the approximate rate of change of revenue from 500 to 501 units is 1480. Well, the actual is 1479.98. Very good estimate. If you ever want to do a derivative of a specific number, you can use your calculator and hit Math, 8, the X key, type in the function, arrow to the right twice, type in the X value you want to use, 500, and then hit Enter, and it will give you 1480, which is what we found for Part A. 11. Comparing f and f prime. Here is f, this cubic, and here's f prime, the quadratic. All right. So now they say graph both of them. We have. All right. And then B says investigate the graph of f near the values of x, where f prime equals 0. Well, where the first derivative equals 0, meaning where the tangent line, or where the first derivative equals 0 is right here and right here. Okay, and here you can see that the tangent line of the original function has a horizontal slope of 0. And same thing here, slope of 0, and so that jives with the first derivative having to equal 0 at that point. So at plus or minus 1, the first derivative actually equals 0, and that's where the original function actually turns from increasing to decreasing, or decreasing to increasing. Now where is the first derivative negative? Well, it's between minus 1 and 1, and that's where the original function is decreasing. Now where is the first derivative positive? It's less than negative 1 and greater than positive 1, so that's where this function is increasing, and that's where this function is increasing. So here are the basic rules that we have learned in this section. The power rule, the constant rule, coefficient rule, the sum and difference rule. So if you look at 9.4, question 1 says what's the derivative of y equals 4? It's just 0. What's the derivative of t? It's just 1. What's the derivative of t squared? It's 2t. What's the derivative of this? It's 3 times 4 is 12, t to the third, 6 times x to the fifth, 7z to the sixth minus 18z to the fifth plus 0. You don't have to write the 0. So find the slope of the tangent to the curve. So you take the derivative and plug in the x value they give you. We take the derivative, we get 14x plus 2. Plug in 2 for the function and we get 30. That is the slope of the tangent at x equals 2. It says also find the instantaneous rate of change at x equals 2. Well, that's the same question. Gives you the same answer. 19, it says find the derivative of each one of these. So this one is minus 1/5 x to the minus 6, minus 8x to the minus 9, plus 0. And you can clean that up by bringing anything as a negative exponent across the fraction bar and writing with a positive exponent. Here you bring the minus 4/5 out front and subtract 1, minus 4/3 out front and subtract 1. You get this. You want to clean it up by crossing the fraction bar to here, and if you want to write it without fractional exponents, you can write it with radicals. 25, before you take the derivative, you probably want to write it this way, with exponentials, not fractions like this. And now it's easier to take the derivative. You bring the negative 5 out front and subtract 1. You bring the negative 4 out front and subtract 1. You bring the 1/3 out front and subtract 1. And then you can clean it up again by writing these with positive exponents or radicals. Write the equation of the tangent line at each of the indicated points. Alright, so you take the derivative. Well, you first have to find the actual point. They only gave you the x coordinate, so you plug in 1 into the original function and you find the y value. So now you know what point you're looking for. If you want to find the equation of the tangent line, you need the slope. So you got to take the derivative, which we do here, take derivative here, and plug in 1. And now you know the slope at that 1.13. So now you use the slope and that 1 point to find your equation of the line. And if you check it, you can see it touches at the point 1,3 right there. It's the only point it touches at, and that is the equation of the tangent line at the point 1,3 for the original function of x cubed minus 5x squared plus 7. Same idea with question 30. You want to rewrite this so that it's easier to take the derivative, but you plug in minus 1 into the function and you get 8/3, so there's your 1 point. But now when you take the derivative, you get x squared plus 9 over x to the 4th. There's your derivative. Plug in your x value for that and you get your slope at that point. So now you've got your slope and your 1 point. You plug them into the equation and solve. And so now you know that that's your equation of the tangent line, and that's what you get right here at -1, 8/3. There's your tangent line, there's your original function, and the graph matches what we found. 31, same idea. You take the derivative, and they want to know where the graph has horizontal tangent, so you set the first derivative equal to 0. Find out where the slope equals 0, and you find that it equals at 1 and at 5. And they want to know what points you find where you have that horizontal tangent, so you got to find the y coordinate. You plug 1 into the original function, 5 into the original function, and now you've got your 2 points here. 1, -1, and 5, 31. These are places where the tangent is horizontal, meaning slope of 0. 43, find the derivative. So we take the derivative, we get this guy here, graph both on the same grid. We did that. And then C says find where the first derivative equals 0, where it's positive and where it's negative. Well, the first derivative is equal to 0 at -1 right here. First derivative is positive for x less than -1. And the first derivative is negative for x greater than -1. And then D says use the graph of f to identify places, x values where f has a max or a min, where it's rising and where it's falling. Well, there's a max or a min where the first derivative equals 0. Okay, that's at -1. And the actual point is -1,9. Where is it rising? It's rising for x less than -1, and it's falling for x greater than -1. 47, suppose a wholesaler expects that his monthly revenue in dollars for an electronic game is given here. Find the marginal revenue and interpret it for the quantity sold. So you've got the original function, you take the derivative, you get this. And the marginal revenue for 300, you plug 300 into the function, you get that, and that's the change in revenue from the 300 first unit is sold, is going to be about $40. So after selling 300, $40 is the revenue from selling the next unit. Plug 600 into the function, and that's the expected change in revenue from selling the 600 first unit. And notice it's is -20. You're actually losing revenue from selling the 600 first unit. 51, demand function. They give you the demand function and they say find and explain the instantaneous rate of change. And so they give you Q equals this, and you might want to write it this way to make it easier to take the derivative. And so when you take the derivative, you get this guy here. And so there's your derivative. And now when P equals 25, you plug 25 into the function and you get -4, which means the price changes If the price changes to $26 from $25, the quantity demanded will be 4 fewer units. Now you plug 100 in the function, you get minus 1/2. It says, so if the price changes to 101 from $100, the quantity demand will change by negative 1/2, meaning it will be 1/2 fewer units being demanded. 53, they give you the cost function and they tell you the average cost of producing X units is given by this function here. Find the instantaneous rate of change of the average cost. So you're going to take the derivative of this guy here. And so it's better to write that as x to the negative 1. So when you take the derivative and simplify it, you get this guy here. And now part B says find the level at which the rate of change equals 0. Well, you set that derivative equal to 0. You want to clean it up by multiplying by powers of 10 to get rid of your decimals, and x squareds to get rid of your fractions. And then when you factor and solve, you get 200 and minus 200. Well, level of production can only be 0 or a positive number, so negative 200 units doesn't make sense. But if you plug 200 into the function, you get 95. All right? And so, what did you notice? Well, we noticed that C of x is your total cost, and it's continually increasing. C of x bar, or the average cost of producing X units, decreases to 95, and then it increases. And that the change in the average cost is negative, and then it's 0, and then it's positive. So at 200 units, the average cost is at a minimum. You can see here it's at 140, and it decreases to here, and then it starts to increase again. So if you want to minimize your costs per unit, you would want to produce 200 units, and that would produce a cost of $95 per unit. 55, here's your cost function, and you want to rewrite it this way. So when you take the derivative, it's easier to do, and you get this guy here. It says find the rate of change of the cost for impurities of 10%. So you plug 10 into the function and you get negative 1200. So if the impurities change from 10% to 11%, then the cost decreases by 1200 because it's negative there. All right? And so there you go. I actually plugged in 9.9 into the function, 10 and 10.1 into the function. I got these values. And I did the same thing. I plugged in these numbers into the first derivative. And so I found that the slope of the rate of change between 9.9 and 10 is negative 1210. And the rate of change between 10 and 10.1 is 1190. And so it makes sense that the rate of change at 10 itself is going to be in between those two at 1200. So that jives with our answer that we got.